A shock absorber is a mechanical dampening device used on a vehicle to control the amount of movement in the suspension and to ensure that the tires remain in contact with the road. When a shock absorber is compressed, oil is forced through small holes in the shock absorber valves. Most shock absorbers have multiple valve stages designed to control different driving situations. Even when driving on a flat, straight road, there are small variations in the road surface. The tires and suspension springs absorb about 1,500 movements per mile, about 1,000 movements per kilometer. The first-stage shock absorber valves limit the fluid flow rates to stop the wheels from bouncing up and down. When these valves become worn, more fluid is able to move through the valves, reducing the damping effect. This allows the springs to keep the wheel bouncing up and down, impairing the ride quality, causing the tires to not remain in consistent contact with the road, and often causing a rattling or thumping noise when driving over road imperfections. Larger movements in the suspension use the second-stage valves in the shock absorber. The second-stage valves are a series of discs that flex to allow fluid to move in and out of the main chamber. Constant flexing eventually weakens the discs so that they flex too easily. As a result, worn shock absorbers allow bigger than normal suspension movements. In this video, we show the way that the second-stage discs affect the vehicle steering. Turning the steering wheel causes the vehicle to lean. With worn shock absorber valves, the initial steering input causes the suspension to compress and direction changes are delayed. The steering angle also needs to be increased to compensate for the suspension compression. Valves on good shock absorbers limit the suspension compression, causing the vehicle steering to feel more responsive. When the second-stage valves have flexed to their full extent, the third-stage valves come into use. These valves allow fluid to leave and enter the main shock absorber chamber rapidly and are used when the suspension travel is most extreme. Worn shock absorbers allow excessive dive and squat under heavy braking and acceleration, which can reduce the tire's grip on the road. Extreme suspension movements, such as when hitting a large pothole, can also result in the suspension compressing or extending to its limit, with the springs then causing the wheel to bounce back because the shock absorber fails to dampen the rebound movements.